Let's get started. Hello, and welcome to today's webinar, How Tyson Foods Instantly Responds to Evolving Market Conditions by Creating a Consistent Data Model. I'm Laurel Ackerman, Marketing Director at AtScale. Before we get started, I want to mention just a couple of housekeeping notes. All participants in today's webinar are in listen-only mode. We are recording this webinar. All attendees and everybody who registered will be sent the recorded version of this webinar after the event. I also want to let you know that we will be opening this up for Q&A at the end, so please add your questions in the chat box at the bottom of the screen and we will take them at the end of the presentation. Let's launch into the agenda. Could we see the next slide? Thank you. Today, we're going to learn how Tyson Foods is able to shift from just the numbers to actual insights, turning data into information that drive economic outcomes. We'll learn how to develop reusable building blocks for analytics to quickly adapt to change, test new ideas for developing insights in minutes and hours, not days and weeks, and create a single version of the truth for the enterprise. And now I would like to introduce today's speakers. We have joining us Chad Walquist from Tyson Foods and Dave Mariani from AtScale. Chad is the Director of Data Strategy and Technology at Tyson Foods. He has 13 years of experience in building large-scale enterprise systems and is now leading a team solely focused on bringing technology that's not only new to Tyson Foods, but new to the marketplace in getting that into place. Chad is one of the founding executive board members for the University of Arkansas Blockchain Center of Excellence. And his experience in advanced technology ranges from AI and ML to robotics, drones, blockchain, and deep learning. Chad, thank you for joining us today. We also have with us Dave Mariani, co-founder and chief strategy officer at AtScale. And prior to AtScale, Dave was VP of engineering at Clout and at Yahoo, where he built the world's largest multi-dimensional cube for BI on Hadoop. Dave is a big data visionary and a serial entrepreneur. So thank you again, Chad and Dave. And Chad, I will hand this over to you.
Thank you, Laurel. So I'm Chad Walquist. Like Laurel said, I lead our analytics, technologies, and platforms, really solely focused on analytics. But I thought I'd give you a little background about what I do, what Tyson Food does, and to kind of give you a scale and set the foundation. So just to hear is a few by the numbers of the sheer scale that we work. So 45 million chicken a week. It's huge volumes that we're doing to feed the world, really. And you think about the metrics that we look at across the United States, it's like 1 in every 5 pounds of protein that people consume in the US comes from Tyson Foods. And so think about the sheer scale. We've got 144,000 team members across the United States and now really across the world, $46 billion in sales a year. And we've really started to embark on a journey through digital transformation. We've had a few progressions, and I'll walk you through some of those things, but also how we're really in the search for true massive scale, and how do we quickly turn around new ideas and test things. So how do we build a connected, data-driven organization? So I'll walk you through some of that today. And then we're really heavily investing in automation, innovation, moving to the cloud. And as those are key enablers to unlock some of the vision that we have about how do we turn Tyson into a world premier protein provider. And you can see kind of one of our lines here is feeding the world with purpose. So we really do see that what we're doing is a good purpose, a true purpose of making sure people have access to quality, good, safe food. So just a little background on Tyson, and we'll go to the next one here. So what do I do? Analytics technology platform is pretty broad. So a couple of things just to line out kind of my role and scope and to set the ground for work for some of the principles we have. So collaboratively define data strategy. So I work with my peers. What is that strategy? How do we utilize data to make better business decisions? How do we create systems to be able to answer those questions, ask bigger questions, more complex questions of the data in our enterprise? So I'll walk you through some of kind of how we do some of that. We also own master data systems. My team works on building the core analytics platforms. We support them, we implement them, and really we take this platform approach, not, hey, I've got a bunch of tools, we're gonna stick them together. So we really look at this unified strategy across all the tools to create a platform that we build things in, because that platform allows seamless integration across the tools, and we can walk you through how we do that today. The last thing I just want to touch on too is the data as code. So we look at data as a way for us to unlock value. So often in traditional world, data was its own thing. I had applications and I could do CI/CD, I could do all these type of deployment. No one was doing that in data. And there's a lot of benefits about how you could leverage those concepts about how I treat applications if we start to apply those to data. And you'll see some of those principles as we go through the presentation today. Just want to walk through the core design principles because I think these are important, and you can see how AtScale fits into some of these here too. So data subjects are part of a unified enterprise data model. For us, we've got to get out of the silos of having single systems all over the place, because the real value is when we start to connect those together. Take this decision, the data over here for this decision, the data over here for this decision, and start to bring them together and understand what does it look like as a whole. Sometimes I think I'm making a good decision in my spot and it has downstream effects that's negative for someone else. So as Tyson as a whole, we don't end up in a better spot. So connecting those data pieces together into a unified data model is a really important concept for us. Separation of concerns, you'll see one of the reasons we like AtScale and the semantic layer is it helps us separate the concerns of data visualization and where that data lives. And so that separation of concerns allows us to be really flexible, loosely coupled, and allows us to be pretty nimble in how we work. The don't repeat yourself, the dry principle. And so this is really just reusable building blocks. How do I build something once? How do I have one version of material, one version of location? And then also taking those concepts into the no ops. So how do I have systems that are very specific, open close methodology about when I bring data in and when I have it out, and where does all my business logic live? And that's important concepts when we start talking about how we use AtScale. The other thing is when we start looking at the end user experience, online reporting, getting out of Excel. I mean, Excel is everyone's favorite BI tool, but how do we get out of just the numbers in a spreadsheet? How do we get off of extracts from all these systems? And now I've got 14 different versions of the truth. So how do we bring all those things together in an online reporting tool? Because we got to make it efficient, cost effective, fast, ad hoc. So really that unified enterprise data model that I'm talking about, we'll show you how that helps us kind of have ad hoc reporting with guardrails, right? So we make sure you get the right answer, it's performant. The last two things here, I'll talk, and you'll see a little more about a program that I'm responsible for called Data at Tyson that encapsulated a lot of these principles into actual real working code and platforms, and we'll walk through some of those today. And then data models represent a digital twin of our business process. I just want that to sink in for a second. Like, a data model, it represents something happening in a system. That system is supposed to support a business process. If we can really create rich data models that connect together, we start to actually map out our entire business process as a digital twin. Now, if I have our business processes from these systems replicated into a digital version, can I start to ask it questions and gain those insights, not just the number about how much I'm producing, where things are shipping, how much money I'm spending. And so that's another key concept we look at. I just want to give you a quick kind of journey. I think this is probably pretty relevant for a lot of people. We started off, we love OLAP. We love the ability to give that guardrail where I can get answers to questions, and it allows the concept of dimensions and measures and all this stuff to come together. So we're a big Kimball methodology shop. And so we like dimensional data warehousing, OLAP, SSAS, SSRS, SSIS. That whole suite is where we had started, actually probably before 2015. It was 2010. We were building it. People loved it. The problem was we started to run into processing power. So how do I scale it? Well, you can see, okay, well, let's just make multiple versions. Let's have one that's got this data, one's got this data. We quickly fragmented and found that that wasn't a scalable solution. So that's actually one of the reasons we ran into AtScale was we started to say, okay, we need more scalable solutions. So we started to go to Hadoop. Down that Hadoop path, we realized that's not the answer to everything either. It's good at certain things, but it's not good at OLAP. And so AtScale was something we actually had originally brought in to help us accelerate some of the Hadoop BI experience, to give that OLAP cube thing that everyone loves, but on a scalable backend. Well, we quickly found how much fun Hadoop is, which not too many people think Hadoop's much fun anymore. And so we actually stood up a big Hadoop cluster, and then we had some switch in our leadership who said, hey, we're going to open up the capabilities in the cloud now. So at that same time, it very much well aligned with how AtScale started moving to the cloud as well. So we actually moved some of our Hadoop workloads to Redshift, put AtScale on top of that. And so we had more horsepower to us. Now we could scale up a Redshift cluster in the cloud. I'm like, this is cool. It's getting a little better. So that progression, you can see. The other thing I'll just call out, you see the HANA across the top. We also started to say, hey, we need that in-memory experience. So we were kind of having a hot and a cold area, a HANA, a fast layer for this, and a Hadoop and AtScale for this other big data. Well, it caused just as much fragmentation. I got data all over the place. So you can see now where we've gotten is we've got this really good hyperscale backend. We're a BigQuery shop. We use some Redshift. We're multi-cloud. But putting AtScale on top of that massively scalable backend with BigQuery, and then opening it up for the different tools of choice. So we use Tableau, Power BI. We've got custom applications, and then everyone's favorite Excel. But it all hits one data model. And so as we look at that one data model on a hyperscale backend with BigQuery, we've solved a lot of these problems where we had these fragmented systems for this purpose, systems for this purpose. Now we're building this real core piece of AtScale on top of BigQuery, and then exposing that out to all of our other applications. All right, we'll go on to the next one. So real quick, you heard data at Tyson. This is a fun little teaser slide, but basically we're trying to make data available, data availability that has scale. We can infinitely scale, we can ask any questions, it's secure, and all sorts of different modalities. So I won't drain that slide. We'll go next year. So why? Like, this is some of the things you just heard me talk about. We want to go to those no-ops, advanced analytics. We want to be cloud native, separating storage and compute. So all those base principles we were going after with Hadoop and Redshift and getting to the cloud, that's really the core principles that are driving us going forward on data at Tyson. So a little more into there, we actually just really launched end-to-end open platforms that I was talking about, and we'll see some examples here. Actually November 1st. So data at Tyson went live November 1st. We're starting to onload data sets. We're starting to ingest them. We've got thousands of tables coming to our lake, and I'll show you what our architecture looks like as well. But really, this is the progression we're trying to shoot for, is how do we start to have that single scalable source of the truth, heightened BI, data catalogs, workflows, descriptive analytics, and then really setting the stage for the prescriptive, the optimization, the feedback loops, and all of that to then feed into the autonomous decision-making. Can I automate processes? Can I build machine learning on top of this? So you'll see all that stuff as we start to integrate all these things together. And then this is a little more of the building blocks. So building blocks, and I'll say why these are important here in a minute. Building blocks allow us to move quickly. It's that whole dry concept where I'm not repeating myself. I create this version. It helps in a lot of different ways, but this is just, I'll just give you kind of a peek into how we look at things. So we've got all sorts of different sources of systems, anything from SAP to Workday to whatever other system you have. And we've built a really rich ingestion platform. It's actually something we've built in-house that allows us to ingest into our data lake. And so we've got a tool we call our data ingestion computer engine, DICE, and that wholesale brings that data into the lake. But now I've got thousands of tables. You know, we've got, I think, a couple, 2,000 to 3,000 tables. We've got another couple thousand queued up from SAP that are going to be coming into this data lake. And really, our lake is a raw layer, but our goal is not to expose that raw data lake to end users, maybe some data scientists and some of those folks, but really the end consumers shouldn't be hitting the data lake. The data lake we look as an enabler to put all the data sets together and then quickly build the building blocks. So as you can see, as we move from left to right here in the lake, is I've got a bunch of small little things all over the place. And you can see those things starting to form through the layers. So now I've got ingested, I've got raw. And then you go over to the hub, that's where we really think about like third normal form. We start to create an item master. We start to create materials, like all of those building blocks you can see are the things that we start to put together. The next layer, as we get that hub and into analytics, now I really model it in a way that makes sense. So that's where we talk about that digital twin of our business process. Can I build these, put these building blocks in a way that represents how our business actually operates? And so as we move through these layers, we've built tooling, and all this runs in our environment. It's in Google BigQuery, in Google Cloud. All of this runs, and we've got latency of under 15 minutes from source to available in analytics. And so Now we've got near real-time data flowing through incrementally through this environment into a analytics model. And so the reason you'll see that we have an analytics, enterprise analytics, like a data warehouse, we like to have atomic base level data there, but we don't put the calculations there because we have this massively scalable backend that will help us enable those calculations to be more dynamic. So I got base core building blocks around the data subjects that I'm looking for, and that gives us the place to govern it. Now the unlock is, how do I get it in people's hands to do something that actually adds value, right? Because all of this should be transparent. Like, this is all hyperscale, and we want it to be transparent, where the business knows nothing about it, just that when they ask questions, they get good answers and it's quick, right? And so that's the goal behind all this. Write building blocks, put it together, present it out to tools. And so that's where AtScale comes in. We put AtScale on top of our enterprise analytics layer, and that's where we have a Kimball dimensional model. And so, hey, we're going to put item dimension in there, and AtScale is going to bring in all these other transactions. We're going to put it all together, but that core piece is there. Then in our semantic layer with AtScale is where we define calculations. So how we calculate time intelligence, so that way we're not materializing these 14 different versions of time intelligence. That's why we're not having all these KPIs and other on-row or off-row calculations. So it's all about doing it in the right layer. So that core fundamental data lets us have good building blocks. AtScale allows us to iterate quickly. So now I have these virtual cubes where I can test new calculations, new time intelligence. Because it's virtual, I can quickly just create a duplicate cube. I can change cubes and redeploy. I can test that in our dev environment. I can do all that really, really quickly because I'm not having to materialize and move anything. And in parallel, now I can have multiple cubes with different versions in production. So it allows us to do A/B testing. It allows us to have a primary channel and a beta channel. So having that virtualization layer in AtScale, where we can now test things, has been really invaluable. And so you can see we've built everything from Power BI to Tableau. We actually have custom apps that we've written that are hitting AtScale, and then everyone's favorite, Excel. And just a real quick on the Excel piece, we look at Excel as the bridge. That's the entry point, because it's the lowest common denominator for everyone. The goal, though, is to get people online in Excel, not extracting in Excel. And then as they say, oh, that's really cool, now let's show them trends. Let's get them in Tableau, let's get them in Power BI, let's give them in some visualization so that they're looking at those trends and over time. So all of those are, how do we build that bridge to people to come along to that richer, better environment? And then I'm just going to talk about how we use that to respond to change. Why is that important? When something happens, this year's been crazy, but it's not the only thing. Like, businesses, things happen, markets shift, pandemics happen, right? How we use building blocks. So when things happen, it's like, oh no, what do I have to go do, put together to answer the question real quick? By investing up front and creating strong, robust building blocks, that means we can have a place to start. We're not starting from ground zero all the time. And so having those capabilities started to build out, having robust pipelines means I can respond, I can act, I can ask questions in new ways, I can bring in new data sets, because maybe I have all the data sets I need, but I need to get foot traffic, I need to get COVID, I need to, whatever those data sets are. If I've got a robust building block, it's just another block I'm building on top of it. The other thing is the hyperscale and the virtual cubes. When things change quickly, we need to respond quickly. So having backend where I can move tons of data around, I can create copies of entire data warehouses in minutes. I also have virtual cubes where I can create copies, I can change things. Having that ability to do it on the fly, we actually use this pretty often during our COVID response, during SAP Go Live, whatever those were. We actually had teams of people sitting there answering questions as we got them from our executive leadership team. So really cool ways that we can on the fly build these type of analytics and show someone as they ask the question a few minutes later. So that's been a pretty cool way to take these building blocks and all this stuff together. Other thing we found was single version of the truth, giving those building blocks, having all of that environment where I have production of the data that I can test these ideas on. that single version of the truth is so important when crises happen or things change, that I don't have arguments over which data is right. Right. So having that version that everyone can use as their playbook and we trust, now we're focused on adding value, making decisions, keeping people safe, not whose version of the data is right. And then all that bundles up into getting out of, give me a spreadsheet with the numbers, right? We're a legacy analog company. We are in our digital transformation. And as we do that, we've got to get people out of saying, they so much know what has my number been for every quarter for the last 20 years. How do we show trends? How do we start to pull out the pieces that are more granular, the things that people can't just see in an aggregated number? And so our version of this is, how do we make sure that the data that our executive team is looking at is the same data model that every analyst below them is looking at? So that same unified data model is the one that we want when our executive team says, hey, what's up here? And ask the questions all the way down the chain of people digging into that. They've got that same version of the truth. They're looking at the same thing. It's just a different aggregation, because those lower levels is how we get insights that are actionable, that can go add value at the end of the day. And I think that's all I had today. I think we'll hand it over to Laurel.
Thanks. Yeah, we thank you so much, Chad. Tons of great stuff in there. Dave, I'm going to hand it over to you, but I think that you are going to run a couple of quick poll questions before you dive in.
You bet. So let me just go ahead and get that all ready. Okay, Laurel, you can go ahead and shoot with the poll. All right, so the first question, how far along is your company in developing a unified data model? So is it a priority, not a priority? You're in the conceptual phase, still defining the technical specifications, or you're in the evaluation, or you've already done it? The second question would be is, how do you, what do you consider the most important component of a unified data model? And you can choose multiples here. So go ahead and take a few minutes or take a few seconds to answer those, and then we'll reveal the answers from the audience. Okay, so how far along is your company in developing unified data model? Most of you said it in the conceptual phase. And then for the second question, what do you consider the most important? Wow, look at that, multidimensional analysis, consistency of data. It's like and the ability to provide live data access. So those are all really important. It's great to see that multidimensional analysis is still such a high priority for people. And of course, we believe in that. And as you heard from Chad, that's a real sort of driver when it comes to self-serve and self-serve with consistency. Okay, so thank you for that. So Chad's been a great partner for AtScale, and his team are really sort of pushing the limits of what that new cloud data model is. And so what I thought I would do is to show you a little bit of how Chad actually and his team actually does it, and how he gets this consistency and agility that he's talked so much about. So I'm gonna show you a live demonstration today of how we can actually create a data model, what that data model means, how it works, and then how we can enhance it with third-party data. So I'm going to show you first-party data as well as blended with third-party data, somewhat like that Tyson has done to be able to predict, especially impact of COVID to the business. So first of all, where is it that this data model fits in your cloud analytics stack? You can see here, this is typically what you see in the cloud, right? We all start at the bottom here and with the data lake. And Chad showed that that's sort of the landing zone of the raw data. And then a lot of organizations, including Tyson, will actually use that create data pipelines to actually then to land that data into a data warehouse. And that's where the that's where sort of the blessed data is. It's where the golden data is. And there is a path as well for a data scientist, for example, to get access straight through Spark or through one of the other sort of direct data lake engines to get data straight from the data lake. But for the majority, that's the majority of analytics are going to come from that data warehouse. You can see that that in Chad's journey, he started with Hadoop as a data lake without a data warehouse, introduced Redshift as the data warehouse, and then changed yet again to BigQuery. And what's interesting there is that one of the factors for the ease of making those transitions was the fact that Tyson and Chad really relied on a unified data model to begin with. So by creating sort of that firewall of that data model, of that semantic layer, he can then change what's happening back here in terms of his data warehouse or data lake choices without having to disrupt all the consumption and consumers that are consuming those analytics. And those are BI tool users who are using tools like Tableau and Power BI and Excel. There are people using Jupyter notebooks, and then there's custom applications that need that data. So what is like sort of the core concepts that you're going to see today? Well, data virtualization is key. You heard Chad talk about that. By virtualizing data, it means that now we're not tightly coupled to a particular instance or vendor of a data warehouse or even a data lake or a cloud. You can see that Chad and Tyson has a multi-cloud strategy, and say data virtualization is key for that. Also, that unified data model. Look, that unified data model is key so that you have everybody speaking the same language, regardless of how they're consuming it. And the multi-dimensional semantic layer, multi-dimensional, like you said, like a lot of you indicated in the poll, multiple measures and dimensions and hierarchies and time intelligence, all the things that Chad talked about are really the driver for driving consistent and safe self-service. So we've come from an era where it was a free-for-all and people are creating those data models directly in the BI tools. Well, we know that we're in a multi-BI tool environment. Everybody has Excel and at least one other BI tool. Most of our customers have multiple BI tools. So this is a way of having your cake and eating it too. Let the business consume the way they want to consume, but do so consistently with the unified data model. So, so I'm going to show you how we do that. So no more slides about AtScale. Today, all I'm going to do is I'm going to create for you a unified data model. I'm going to do it for my sales data. I'm going to do it for 2020 so that we can try to determine what the impact of COVID was on our sales. And we also want to look at some cohorts. And I'm going to use third-party data using a data marketplace. I'm going to use SafeGraph's foot traffic data. And we're going to use that foot traffic data to augment our own data, our own first-party data, so that we can see what the what our anticipated impact to sales might be and how we're doing compared to our cohorts. So the way this is going to look is that I have my AtScale unified data model, which I'm going to build live. So this is not pre-canned. I hope everything goes well because it's big data. The SafeGraph data is 600 million rows of foot traffic data across all of the US. We have our first party data, which is all my sales data. We're gonna join those into a single unified data model. I'm gonna be playing two roles today. I'm gonna be playing the role of the author of the unified data model, and then I'm gonna take my hat off and I'm gonna be a business analyst that's gonna create self-serve reports and analysis. And I'm going to use Tableau and Excel so you can see how it looks from both sides. Okay, so let's get started. Let's first create a unified data model for my sales. So let's go back to my tool called Design Center. So in this demonstration, we are going to be using AtScale to do this. And this is what a data model looks like. We call this our canvas. And that what you see over here on the right is a preview of what the business analyst or the data scientist is going to see. So this is the semantic layer. This is that universal semantic layer that the BI tool will see. What you see over here is the data model that's built upon our data assets. Now, this is a virtual model, so we didn't physically have to move this data. We just created this data model on top of the data using virtualization. So let's go ahead and let's create this model from scratch. So I'm going to create a new virtual cube, and I'm going to call it, let's call it COVID impact analysis. And I'll go ahead and create that. So I'm just creating a new virtual cube right now, and I'm going to enter into my canvas. So at this time, I have a blank canvas. I'm going to start to add some data to it. So this is how you build a unified data model in AtScale. So first of all, I have some data warehouses here. Today, for today's demonstration, I'm going to be working with Snowflake, and I'm going to go ahead and pull off. You can see I have all the schemas here. This is all discoverable by the tool AtScale. There's nothing I had to do to tell AtScale about this. This is just through JDBC. So I can take something, for example, I have my sales data, which I'm going to drag onto my canvas. So my sales data is now on my canvas. And if I just double click that, I can get into a preview and data wrangling view of that. And let's try that again, because my Snowflake virtual data warehouse needs to come up. And there we have it. Okay. So, so here's my raw data. I can see that I have nested data, and you can see that in my product info. You see I have size, weight, and color. You can see sales reasons is actually an array of objects or array of data. And you can see that I have all kinds of stuff when it comes to, I have dates that are strings. I have dates that are numbers, all kinds of stuff. And that's typically what you're going to see in your raw data. Well, what I'm going to do is I'm going to make this consumable for my customers, right? So the first thing I'm going to do is, obviously, I want to be able to count up my sales. So I'm going to turn that into a measure. So this is where the data model comes into play. So I'm going to take my sales amount and I'm going to drag it into my measures panel. And this is going to allow me to name it. I'm going to leave that name as it is. You can see that it automatically is smart enough to say I'm going to sum it. I'm going to do this for unrelated dimension handling. So what this means is that this is an important, very important aspect of why a data model is so important. I'm going to be blending data from multiple data sources. Those data sources are not going to have the same dimensionality in each of them. For example, the SafeGraph data, I'm going to have stores in SafeGraph that obviously aren't, and businesses that aren't in my own data. So I'm going to be able to do that and blend that data using that kind of a feature. And that's really key and where the data model really comes into play here. So I'm going to go ahead and format it, and I'm going to put it into my sales metrics folder. And right now, if I look at preview, I have my very first very first measure called sales amount. So let's keep going here. I think I want to have my order quantity because I want to know how much of each item each person bought. So I'll go ahead and do that. I'll go ahead and choose my formatting as a number, and I'll go ahead and put it into my sales metrics folder. Okay, so far so good. Now, I need to have some dimensionality here. So all I have right now is a couple measures. Obviously, I'm going to want to sort by that. So this is where conform dimensions, I saw a question about master data management. Conform dimensions are key to allow you to create models that span different data sets. So AtScale has a concept of a library, and this library is where we have our conform dimensions. So now as a modeler, I can just drag on my customer dimension and my date dimension, and I'm going to drag in my product dimension. And I don't have to worry about how those were constructed. I can just use them. And so how do I use them? Well, I take my sales data, which is my sales table in Snowflake, and I just link it up. So watch what happens when I do that. I connect it to my customer key. And what happens over here on the right is that I now have a very nice customer dimension with customer attributes, as well as a geography roll up for where they lived. So how did that all come from just that? Well, if I double click on my my customer dimension, I could see that I have a customer dimension here that is made up of my dim customer table, as well as two other embedded dimensions. That's indicated by the green. So I also have a geography hierarchy, which is made up of 4 different snowflake tables to give me that roll up. But that was all together and all put together very simply into that one object that was reusable. So this is where you get the agility. Okay, so I'm gonna do so you get the idea. I'm gonna go ahead and move a little faster here. So I'm gonna hook up my product. And so now you see my product hierarchy. So everything has been inherited. I'm gonna do some dates. I'm gonna wanna do my ship dates. And I have what we call role playing. So I can say ship and as a prefix. And all of a sudden, now I have ship dates with all their hierarchies and all their attributes. I'm also gonna add in my order dates. So here's my order dates. I'm gonna actually give it a prefix of visit when people visited, and I'll show you how that works later on. And now I have a pretty good virtual cube. Well, I'm not done yet, because remember I had that nested data in that product info field. So for AtScale, it's aware and will be able to decompose that nested data. So I'm going to create a dimension on color and style. AtScale realizes that's a mapped or an embedded field like you see these days. And just by doing that, it creates 2 virtual columns, which I then can turn into dimensions just by dragging them in. Okay, so now I got a pretty good virtual cube, and I didn't do any ETL. I did no data transformations. It's all done virtually. So one thing before I leave here, I'm going to create a drill through view. Now, what this is going to allow me to do is if I create something called customer details, I'm going to show you how this works, is that I can then say, you know what, I want to see a drill through on customer details. I want to see the customer name. I also want to see where they lived, and I want to see what they bought. And so I'll do my sales metrics and my sales amount, and I'm going to save that. And I'll show you how that gets used in just a few minutes. Okay, so now I'm ready to go. I have a nice little data model that you see here, and I'm ready to publish it. So by publishing it and publishing this new COVID model, all I have to do is hit publish button, and that basically sends it to AtScale server and says, okay, we're ready now to start to, that's now public. It's now consumable by whoever I've allowed it to be accessed by. And I'm gonna first start with my Tableau, with a Tableau dashboard. And so let's load up Tableau, and I'll show you what that semantic layer, what that data model that we just constructed, what it looks like in Tableau. And then what I'll do is I'll show you what it looks like in Excel. So here comes my Tableau, and I'm gonna log in. Once Tableau loads here, I'm gonna log in to AtScale server. So now I'm talking to the AtScale server, which is that virtualization server. So not only is it going to give me that virtual data, but here's all these are all the dimensions and folders that you just saw me create or author in that AtScale data model. So now I'm working with a connection to that data. So I'm going to go first with sales amount, and then I can go and say, oh, let's look at sales amount by product. Now, these are live queries against, in this case, this is my Snowflake data warehouse. Like for Chad, Redshift, Google BigQuery, it's the same thing. And the user doesn't know the difference. The data could be coming from anywhere, and that's the beauty of it. So you can see that I have a lot of bike stuff. It's my store, my online store is a sporting goods store. So you can see I have my first query. If I go to my data source tab here in Tableau, you can see that it is a live connection. This is not an extract. So these are live queries. Okay, so let's go and let's do my sales amount. And you remember we had that nested field called color? Well, there it is. You know, it unnested that data and ran a query on that color field, just like a dimension. But what I want to do is actually want to look at my sales over time. So let's do my first. Let's use my date field here, and you can see I have a bunch of different date hierarchies and fields here. I'm going to use my visit, and I'm going to go at the month level. So let's look at my sales by month. And I'm going to go ahead and drag in a filter here. And let's just choose 2020 because that's the terrible year that we've experienced all these issues. And sure enough, you can see that my sales were trending great. COVID hit, almost did a shutdown. I've recovered, but then I've actually dropped off again. So that's how I can see this data. And this is just my sales data at this point, but this is how I can see it in Tableau. So let's see what the experience looks like in Excel. So Chad mentioned that Excel, I love how he said it's a bridge. You really can't decouple and take Excel out of the hands of your business users. But what you can do with a virtualization layer like AtScale and a data model is that you can use, and I'm using the analysis services connector that's built into Excel. I can go ahead and create a live connection in Excel, not a data dump, but a live connection. And you can see there's my COVID impact analysis. This is what I just created, and it just authored right there before your eyes. So I can go ahead and do that, and I'm going to create a pivot chart or pivot table, and you can see there's my semantic model. There's my data model that's the same as what I saw when I just was looking at my sales amount by color that I saw in Tableau. And of course, I can go and create a chart here, and I'll go ahead and do that. And what you see here is that chart looks a lot very familiar and looks very much the same as the chart that I just created in Tableau. So what you see is what you get. You get consistency regardless of what tool you're using. So what else can I do? Well, if I haven't aggregated or pre-aggregated the data, I mean, Chad said something very important. He said that we want to have the data grain in the warehouse. Well, I can do that, like, for example, show me all the people that actually bought a blue product. Remember that drill through that I defined in Design Center? By doing that, I can simply get the raw data of everybody who actually purchased a blue product. And I can do that because I haven't aggregated the data away. Okay, so let's keep going. I'm going to add another sheet here, and I'm going to go ahead and create another pivot table here from my existing connection, so I don't have to reconnect. I can just use the connection that AtScale already has, and so I'll do that. And this time, what I'm going to do is I'll do another pivot report, and this time let's look at our sales data. So remember I had my sales amount. I'll do that. And then my sales amount, let's look at it over time. So here's my visits. And I'm gonna go and put that in the rows. And so just like that, I now have my sales by my years. I wanna only concentrate on our terrible 2020 year. So I'm going to go ahead and create a filter. This is just using Excel pivot tables. And then I'm going to go ahead and drill down. These are all live queries now against AtScale server. So there you have my data. Well, we can obviously see, just like we saw in Tableau, that my sales have dropped in half due to COVID. But what I want to do now is I want to bring in some third-party data from SafeGraph, where I can look at foot traffic for a cohort. And look at that cohort. It's another sporting goods store, and see how they're doing compared to me. Okay, so I want to benchmark that. So what do I need to do that? I'm going to come back to Design Center here, and I'm going to go ahead and come back into my COVID impact analysis virtual cube. And I'm going to come back into that model. So now what I'm going to do is that I'm going to go ahead and add in additional data from my third-party marketplace. SafeGraph is available in the Snowflake marketplace. And so what I'm going to do here is I'm going to go ahead and use my trusted library here, and I can filter by data sets. In my data sets, what I can see is I have my SafeGraph visits by day. So I'm going to pull that onto my canvas. Also, what I'm going to do is I'm going to filter on my dimension, reusable objects, and I have my SafeGraph brand because I want to look at cohorts. So I need to know what stores are sporting goods stores. So now I have a multi-fact model here. So then how does this work? Well, to relate it together, again, the power of the data model, I'm going to take that visit date and I'm going to go ahead and attach it to my date dimension. I'm going to call it, give it a prefix of visit. And just like that, I'm now able to blend data from SafeGraph with my own sales data. And so that brands, I'll go ahead and hook that up. And so now I have a brand dimension. So look what happened. I now have my SafeGraph brand that's in my virtual cube. Not done yet because I want to have a measure and I want to count the number of visits in SafeGraph. So I'll call this SafeGraph visits. And I'm going to go ahead and leave it as a sum. I'm again going to use my my unrelated dimension handling. It is a number, so it's a number of visits. So I'll use a number, and I'm going to put it into my third-party folder. So now I have my virtual cube here in my third party, and there's my SafeGraph visits. Okay, so that's all I needed to do. So I'm going to go and all I need to do to make this new data live is hit publish. So by doing that, I've now added the SafeGraph data to my model. So let's go back to Excel, and you can see that here's my pivot table. And all I'm going to do here is just click refresh. So now that we've refreshed our data in our worksheet, we can see that we now have our new data elements. So there's our SafeGraph visits, and we can just go ahead and check that on, and there we have it. There's our SafeGraph visits alongside of our first-party data, which is our sales. So now I can go ahead and create a chart here. I'll create a combo chart, so we can see how we're doing compared to SafeGraph's foot traffic data during this period of time. So you can see that we pretty much followed that pattern, that SafeGraph is actually showing foot traffic is much more up. So we're actually not fitting this trend. Our sales are continuing to drop, even though in terms of cohorts, it looks like SafeGraph foot traffic is definitely returning closer to normal. So where did this data come from? Well, if I come back to my my Snowflake instance here, you can see that they have a data marketplace icon here. That just opens up a window, and you can see that there's a number of different categories of data that I can work with. And if I look at SafeGraph in my search here, let's just take that out. You can see that there's a number of different things. And I can just go SafeGraph, and I'll see the SafeGraph data sets pop up that I can then access myself. So once I've done that, and once I click on these, what then happens is that that data share will show up right here, and you can see there's the SafeGraph weekly pattern data, and you can see that it put it in a database. That's all shared, and so there's the actual sharing ID. And so if I go to my databases, then I can see that this weekly patterns data, you can see it's 619 million rows. So even though that was big at scale, and the reason why that was so fast is that at scale, if I go to my query screen here, you can see that AtScale actually created an aggregate and used an aggregate. So that 619 million rows, that's the query that came from Excel that I just did. That query ran very quickly. It ran in under 1 second. And it actually ran that query against Snowflake and against that shared data set in addition to my first party data set. So that's really the magic of the data model, is that I can get something like this, easily blend new data without having to do any ETL, without having to do any data engineering. It's really the power of that unified data model. And I was able to do that because I was able to reuse my date dimension, which allowed me to report on data consistently, regardless of where it came from. So, so let's go back to our presentation and let's wrap it all up. Okay. So what we saw here is that our data virtualization, and data virtualization is a key, it's really a key component of the solution, really translates into minimal data engineering. So all that happened behind the scenes without having to move data, without having to get data engineers in to build extracts or to build new data pipelines. And what that also meant is that I had live access to that data. What it also meant is that the unified data model that Chad talked so much about, that unified data model meant that I could easily incorporate new data like SafeGraph and also make it very easy to use in tools like Excel. And then the universal semantic layer that comes with that data model and with that multi-dimensional engine behind the scenes, that's how you get your single source of truth. And with that single source of truth, regardless of how your users want to consume, they're going to get the same great experience with the same governance and the same metrics, regardless of the tool they're using. So, so given that, you know, Chad mentioned, you know, Tyson's running on BigQuery as well as Redshift. You saw Snowflake here. We run on any type of cloud data warehouse or on-premise data. But these are sort of the numbers, and you can come to our website if you want to see the full reports for just how much AtScale, in addition to that great data model that you get, you also get lightning fast performance. So big improvements on all the cloud data warehouses. You're able to add many more users. So that means you get to go faster with the same amount of resource and cost. And that translates into a better overall ROI on your new data warehouse spend. So with that, I'm going to hand it back to Laurel. And Laurel, go ahead and we can take some questions from the audience.
Yeah, that's great. So we have gotten quite a few, and Chad has been diligently answering many of them. Thank you for that. I have all of those answers if anybody ends up needing them later, but we can dive into some ones that we didn't get to yet. Chad, I think there's one that you were maybe wanting to discuss about allowing Power BI, Tableau, and Excel access to the data lake environment.
Yeah, I wanted to answer that because I think it highlights the importance of semantic layers, and not just because it's AtScale and we're here about AtScale. Like, that semantic layer is an important piece of an architecture, and separation of concerns and really having that layer of abstraction away from the source gives us a lot of flexibility. So we don't allow, outside of like data science or some other people that need like the raw data, most of our business is not capable of, not capable, but you don't want business users then they're looking at raw SAP tables, like 4-letter SAP tables, and there's 20,000 of them. Like, it's hard for business people to make sense of that. So generally, we do not let people in the lake with Excel or Tableau or Power BI. The lake is really a place for us to harmonize and bring that data together, make sense of it, and then present it out there to that semantic layer that ends up being that representation of our business process.
Excellent. Thank you for that. Just taking a quick look at where we are. Oh, Chad, another one for you. Were you able to, and if so, how did you deliver a unified data model to the business prior to working with AtScale?
You have a few options. You have a bunch of flattened views or tables, and you got a view and a table for every report, right? So that wasn't unified. You had a different system with, different copies, we're like every big enterprise. You know, we've got a version of material in this one system, and it's got no leading zeros. You got a version of material in this other one, and it does have leading zeros, and all these different variants of it. It makes it really hard to join it together. Not only are they in different systems, the master data doesn't harmonize across things. So we didn't do a great job of that unified data model before. And that was one of the things is we had a system for this, and we had a system for this, and we had a system for this. And we never got to that connected piece where I can understand the impact of the decisions I'm making, and are we driving the outcome we think we're driving? And by connecting those together using tools like AtScale, that semantic unified model allows us to really start to see the connected pieces of our decisions. And that's why we've gone on this path. We tried building really, really big SSAS tabular models. We tried putting in Hadoop. We tried Han. We tried a lot of different ways. We haven't found ways that are as dynamic and scalable as we have in the current environment, with really having this hyper-scalable backend with BigQuery, AtScale creating all the connections and nice UI UX experience. And then I'll mention too, one other thing in that same realm, AtScale helps with performance, but also cost. Some of these cloud providers, one of the things that we look at is, if we're looking at a consumption model, how do we avoid, when I've got 100 users in the same department executing the same report, hitting the same query all the time, having AtScale in there to really act as a buffer and cache, that helps with the performance, but also the cost, because I'm avoiding hitting those cloud data warehouses. And that's been a big reason we've chose to go this route, is having the speed and the cost, and then having a really nice user experience.
Thank you. That's a lot. That was a great, thorough answer. Another one, we're getting questions from a number of channels. Somebody wondering how you organize, or if you have thoughts on the best way to organize your team at Tyson to deliver analytics to the business.
That's a great question. So we bring up internally, we like to separate out concerns on our teams as well. So we get people to be really good at certain things, but then we also have that kind of common thread across them. So we look at governance, cataloging, all those things as kind of the layer that goes across the different teams. And so my team is very much about, hey, how do I create these platforms and strategy for how we use these platforms? And then I have some peers that, I have one peer, she is bringing in the ingestions into the platform, and also the integrations in and out of the platform. I have another peer who works on the data model and the visualizations on top of that. And so we look at it as, between the three of us, for example, we can build anything from top to bottom in the analytics space. And I have another peer that does data science on top of all those platforms. So my team helps build that core platform, and then other people come in. But again, that comes to that concept of platform. It's a platform we build, not a set of tools that everyone stands up their own version. And that gives everyone into one place looking at the same thing. So we separate our teams on function like that so that we can really operate efficiently.
Super interesting. Thank you. Dave, I have a couple questions for you actually now. So you showed AtScale working with Tableau and with Excel. The question is, how does AtScale work with other BI tools that people may be using?
Yeah, there's a bunch of interfaces or protocols you can use to connect a tool to AtScale. One is SQL. So you saw the SQL interface using Tableau. That's how Tableau speaks to AtScale. You saw the MDX or XMLA interface with that live connection to Excel. And then for Power BI, it's through DAX. So the key here is that whatever the BI tool is, we want to give the best, most complete experience so that there's no compromises with those BI tools. That's why, look, Tableau loves SQL. They don't like MDX as much. And so that's why we support both interfaces, but SQL is a much more powerful interface for Tableau. So whether it's SQL, MDX, or DAX, or just a REST interface that you can use and knit into your custom applications. You can query that unified data model in virtually any environment or any tool.
Great. And then this might be kind of a big one, Dave, but I'll pass it over to you in the time we have left. Somebody's saying, is AtScale a data modeling tool, or OLAP cube storage tool, or schematic layer, or ETL tool? It looks like AtScale can help with a number of things. What the question is, what's the uniqueness of using
That's a
AtScale
great
to
question.
sort of do all those things?
Yeah, the uniqueness is the blend of everything you just said. So first of all, the ETL, what I didn't show you, and because we just don't have time, but we call it autonomous data engineering. So the reason why those queries were so fast is that we were building aggregates in Snowflake in this example behind the scenes, and that's what accelerated those queries. So and of course it's an OLAP model, which is why you saw measures and dimensions and hierarchies. And there's full MDX capabilities for creating calculations, again, which I didn't show you. So it is a multidimensional model. It is a modeling tool because we're creating a model on top of our raw data. And it's a data virtualization platform, which is how we deliver the live connection. So to me, those are, and we have a buyer's guide for data virtualization and coming up for semantic layers that really sort of spells out what these requirements are, because you can't have a universal semantic layer if you don't check those boxes. And so, sorry, it's not an easy answer, but it's all of the above, basically.
Excellent, thank you. I think that's just about all the time we have today. Thank you, Chad and Dave, both for a really thorough presentation, really interesting. And for everybody who joined, thank you so much. If you have additional questions after this webinar about the content of the webinar or questions related to your own situation and architecture within your organization, you can email us at hi@atscale.com, just hi@atscale.com, or you can go to our website and get in touch with us that way as well. So thank you again, everybody.
Thanks, everybody. Thanks, Chad.
Thank you.